Good evening, everybody, and welcome to the virtual public information meeting for state project number 44-160, replacement of bridge number 4074 on Fairhaven Road over the Pattagansett River in the town of East Lyme. My name is Mark Burns, and I'm the program manager for the local bridge program. Here are some quick ways to contact us by project email at dot-flbp@ct.gov, by phone at 860-594-2020, which is a monitored voicemail line. And we encourage you to access the project webpage located at the link shown below. In order to use closed captions and subtitles in Zoom, on the bottom screen below, you can click Show Captions CC, click the speaking language, and select the language you would like from the list shown. Closed captioning, including non-English translation options, will also be available on YouTube following the live event. Following the presentation, there will be a live Q&A through the Zoom Q&A function. Also on the bottom of the screen, there's a Q&A button. You can select that tool at the bottom of the webinar window, and there will be a pop-up for a question and answer window. Type in your question and then click enter, and the project team will answer it. If you're an audio-only participant, please dial *9 to raise and lower your hand. As I stated, my name is Mark Burns, and I'm the project manager at CTDOT for the local bridge program, and this is my contact information. Email is always the best way to reach me. During the Q&A, you can reach out to us by email at dot-flbp@ct.gov, by phone at 860-594-2020, which is a monitored voicemail line, and through the Zoom Q&A. But please keep in mind the Q&A is only available during the live session. But we will have a comment period open until January 27th, 2025. And again, the link to the project webpage is shown below. I'm going to read this slide on Title VI, Civil Rights. No person on the basis of race, color, or national origin be excluded from can you go back one, Connor?
Sorry.
All good. No person shall on the basis of race, color, or national origin be excluded from participation or subject to discrimination in the development of this project. We highly encourage you to fill out the voluntary post-meeting survey located at the QR code and project link shown, and there's a link to show the Department's Office of Equity Title VI Civil Right page. A recording of this presentation will be posted to YouTube after the event. Closed captioning, including non-English translation options, are available on Zoom and YouTube. This is a slide, I won't read this, but this is our slide regarding Title VI Notice to the Public for Civil Rights. This project is funded through the Federal Local Bridge Program's Design Managed by State, or DMS program. In the past, under the Federal Local Bridge Program, funding was an 80% federal reimbursement with a 20% town match for design, rights-of-way, and construction activities. Under the DMS program, design, rights-of-way, and construction phases are funded with 80% federal and 20% state funds. Design, rights-of-way, and construction will be at zero cost to the town. And even though the town has requested that we undertake the design, it is still a full partnership, and we've been coordinating with the town at all project milestones, which is why we are here tonight presenting to the public at 30%. The goals of the DMS program were to provide a streamlined approach to design using full DOT resources, to aid the towns to keep their bridges in a state of good repair by effective use of funds, decrease typical design time from 60 months plus to a 24 to 36 month design timeline, depending on permits. When applicable, utilize accelerated bridge construction, or ABC techniques, to shorten construction duration, and most importantly, to increase the number of municipal projects delivered in each construction season. I'll now turn over to Joe Bragaw, Public Works Director, for some remarks. Joe?
Yes. First, I want to apologize. The first selectman, Dan Cunningham, did want to be on this Zoom call, but he was pulled away to another meeting. So I'm here representing the town. I also have my Deputy Public Works Director, Alex Close. It's on this Zoom call. I just mainly want to reiterate the last slide that the town of East Lyme is aware. We requested a DOT to enter this program. We think it's we want to work together as a partnership. There are some issues. We've had barriers up on the bridge. The railings are deteriorated. The bridge needs work. We've been working with the DOT, and part of this process is we're the conduit for the town. If residents have any issues, they certainly call the DOT. They can call us. We're all working together on this project to make it a successful project for all. And there's a lot of information in this PowerPoint, so I will kind of keep it at that right now. But we are working as a partnership with this group, and we look forward to a successful project.
Great. Thank you, Joe. Representing the department and VHB, our consultant liaison. From the department, Bart Sweeney, our Division Chief of Bridges. Derek Lassard, the Principal Engineer of the Consultant Design Unit. As I stated, I'm Mark Burns, Project Manager. Jeff Organic is Project Engineer. Representing the Office of Rights of Way is Zach Garino. And representing VHB, who is our Consultant Liaison, are Mark Levesque, Program Manager, and Connor Oakes, Project Engineer, Structural Engineer. It's a brief slide showing some key structural bridge elements. The traveling or driving surface, otherwise known as the deck, is shown. Preventing vehicles or pedestrians from hazards are parapets on either side of the deck, and in the case of this bridge, there's temporary barrier. Supporting the deck and parapet is the superstructure. In the case of this diagram, is made out of steel beams. Supporting the remainder of the superstructure are the abutments and piers, otherwise known as the substructures. Depending on the span of the bridge, you might see one or multiple piers, or if it's a shorter bridge, there won't be any piers present. Also acting as earth retention on the abutments are wing walls. Bridges are inspected biannually by the department, and then they're given a rating from the key elements on a scale of 1 to 9, with 9 being in excellent condition and 1 being an imminent failure. Please don't let that alarm you, because while the bridges are inspected, if there was any concern, that the Office of Bridge Safety would alert the town to make corrective action. I'll now turn it over to Connor Oakes for the formal presentation. Connor?
All right, thank you, Mark. Good evening, everyone. As stated, my name is Connor Oakes. I am the project engineer for the proposed project we are here tonight to discuss. And I'm looking forward to telling you guys more about it. And yeah, so without further ado, I'll get started. So this is the reconstruction of Bridge 04074, which is Fairhaven Road over the Pattagansett River. For any of those who are not directly familiar with the location of this structure, you can see to the right a location map, which will show that the bridge is approximately 1/3 of a mile southeast of Route 156, 500 or so feet west of Gotta Road. And then some important facts to know about Fairhaven Road is that it is functionally classified as an urban local street. The latest DOT traffic count published is 1,802 vehicles per day. However, the town of East Lyme did do an independent study in 2024 that indicated a similar number, but the most recent one is just over 1,900 vehicles. As you can see here, just another aerial view, which gives a better characteristic of the surrounding area, which is lightly developed residential. There are no sidewalks going over either side of the bridge or in the near vicinity of the structure. And as you can see on the south side of the bridge, I should mention, there are a few docks shown there, and others upstream as well that would not be shown. So as we can see here, some photos of the bridge itself. So on the left, you would be standing on the road, looking across the bridge at the west approach. You'll see to your left, the left side of the left picture, the red historical barn, which will be protected throughout the duration of the project with particular attention. You'll notice also there are overhead utilities on that side of the bridge. We will get more into this later. There will likely need to be some temporary utility relocations within construction easements for this project. And then on the right, you will see very clearly the deteriorated rail, the temporary barrier. We are looking across the bridge at the east approach there. So on the left side, we are standing at the west approach of the bridge, looking towards it. So you can see a good look at the pavement condition and the shoulders of the existing west approach. And then vice versa on the right side, we're standing at the beginning of the east approach, looking toward the bridge. Moving on. In this photo, you'll see just some side views of the bridge. So on the left, you are on the south side where the utility wires are running. The barn would be to your left. And then on the right, you're standing on the more north side of the bridge. The river does run north to south. There is also tidal flow. And again, you can see the barriers, railing, and utilities there. So to the left, you are looking upstream, and then to the right, you are looking downstream, and we can see those docks that I mentioned earlier on the location map or the aerial view that we were looking at. So a little more about the project in general. Why are we doing this? The purpose is to address the noted structural and functional deficiencies by replacing the bridge, improve hydraulic performance, and leave the structure in a state of good repair for the future users. So as mentioned, the bridge is functionally deficient due to narrow curb-to-curb width. The existing curb-to-curb width is 23 foot 8 inch. With the barrier in place, it's 20 foot 6. And it must be widened and then repaired in order to meet current standards. The reason for the barriers, as mentioned, is the critical condition of the railing, which we'll look at a little closer. Some more information. So Mark went through some bridge elements earlier. In the picture, we're shown steel beams. So we'll look at a better picture to show this later on, but this existing structure is precast concrete box beams supported on reinforced concrete abutments and then founded on steel piles. So it was originally built 1970, 57 feet long. It's 24 foot out to out, meaning the outer face of railing to outer face of railing. 23 foot 8 curb to curb, which as mentioned is reduced to a deficient state. And even with a low speed limit of 25 miles per hour, that's unsafe for a bridge. Just a view showing some figures, the low chord elevations here on the upstream side. As mentioned, the existing superstructure is made up of precast concrete box beams, which generally look like, as you see here, there would be reinforcement running through them, not shown. Yeah, as mentioned, the existing bridge is functionally deficient due to the narrow width. It is considered basically intolerable. If you recall from the previous slide, there was the conditions rating from 1 to 9. So due to the intolerable nature of the deck geometry, the barriers were put in place to make it temporarily acceptable. A little more into the aspects surrounding the project. So typically with bridge reconstructions, there will also be some full depth pavement work. And although the approaches are in satisfactory condition per the rating, there are issues that could be mitigated, such as transverse cracks, where there are seams in the pavement, which you can see in the middle along the yellow line. This is the existing bridge railing. It is the top rail, which is, I mean, more important than the whatever length of this loss here is. I think that we see that the existing railing is the width of the tape measure approximately. We have barriers in place, and the new bridge would have a modern rail system, protective coating for the surrounding elements. If you look under the critical rating verbiage on the slide, you'll see some facts about measurements and such related to the railing. So the existing superstructure is also rated satisfactory. The 8 box beams are approximately 3 foot wide each, 57 foot long. There are spalls or deteriorated areas where it is popped out. Loose concrete, you can see in the bottom photo a zoomed in area of one of the spalls where it has also begun to crack. You can see dampness. There has been the intrusion of moisture. To the right, the joint, the foam material, you could see at the very bottom of the photo is starting to squeeze out of the joint a little bit. So the substructure is again rated a 6. These are the reinforced concrete abutments, which show some scale and voids at the bottom. There is undermining beginning to occur, and but obviously this needs to be addressed. As mentioned, the other critically rated element is the approach guide rail. The first and third wood posts are broken. You can see that this one is tipped like completely out of the ground. So it's not doing anything to protect at this moment from errant vehicles. All posts show weathering, and the wire rope exhibits rust throughout. The channel itself is considered very good. There is large boulders up to 6 feet in diameter at both abutments. And a benefit is that the old abutments from previous bridge were left in place as countermeasures for scour. The scour is considered to be stable, due in part to the measures currently in place. So this was not necessarily a concern of the initiation of this project. However, it is something that we seek to maintain in its current rating. As mentioned, there are overhead utility wires which would require relocation prior to the start of construction or any associated crane work with the project. So there will be electrical, telephone, and cable wires running pole to pole, which will remain in service throughout the project. The bottom right photo, you'll see kind of about the side where we may propose a water main. It would go on the side of the bridge as shown. That's what that is meant to display. So the replacement bridge will be, again, ASHTO precast concrete box beams. They will be covered in a 6-inch minimum shear slab with cold liquid waterproofing and a HMA wearing surface. So the as you can see in the pink, this is the new 3-tube modern galvanized bridge rail, which will be resistant to further corrosion and is crash test rated and safe for vehicles passing over. You'll see that there is a proposed sidewalk for the bridge. The new structure will be 31.5 foot, 26 foot curb to curb, but 31.5 if you include the 5.5 foot wide sidewalk. So this is a elevation view of the proposed new structure. So the structure will be increased from its original length to a 215-foot total length, which will be two 100-foot clear spans with a center pier. This will all be founded on piles and will require the widening of the existing channel as shown. We'll need to remove the lines that you see here. We'll have a better picture on one of the next slides that'll show exactly what's going on, but basically we're going to run the bridge as shown. The bridge will be the orange, the yellow will be the reconstructed roadway, including any and all driveways affected. The blue is the water course, and then as you can see on the north side of the bridge is the sidewalk. So just want to make sure I didn't miss anything. So this is going to be a project where the road will be closed for the duration of construction. As you can see on the right, and may or may not be able to read, the 6-minute detour is approximately 2.5 miles end to end. And it will reduce the construction duration cost. So environmentally, there are the state listed species on site. So the northern diamondback terrapin, which is turtle, could potentially be influenced by project activities. Measures are provided and required for bridge work between April 1st and 31st for the turtles. There are also northern long-eared bats present in the project area. CT deep fisheries is required to keep at least 50% of the existing river channel open for fish widthwise at all times. The river is tidal at the bridge, supports various fish, which you can see there. Particularly the alewife fish, which will be protected from migration between March 15th and May 31st for unconfined water work, artificial lighting, and loud construction noise. Further environmental considerations. There are some archaeologically sensitive areas due to the proximity of the river and other environmental components. Barn at the southwest quadrant may be historically significant, and it will be avoided throughout the duration of the project. And then any impacts to the historic stone walls would require additional evaluation. However, it is more likely that they will be avoided rather than reconstructed. So there was a hazardous materials screening performed, and essentially that is indicating that there is some lead-based paint and other materials that would require abatement prior to the bridge replacement. There will be permits associated with the construction project here. So there'll be flood management, Army Corps, Coast Guard, and wetlands permits. You can see what we expect to be needed here. So the right-of-way will be impacted through as necessary, but minimally throughout the project. So I will give a quick explanation of what exactly is going on here so that we can all be aware. So the blue areas that are shaded, just temporary access areas which will be needed to construct the bridge. So the thick dotted black line which you see running along the road is like a wing wall or a retaining wall, which will be supported on piles. So in order to get vehicles around wall, men and equipment, we will need to have a little bit of access to the property as shown on all 4 quadrants of the project. In the center, you will notice the red shaded areas, which are permanent property takes as needed for the widening of the channel and the excavation of the soil, which the bridge will now pass over as open water, previously shown. You may notice some smaller red areas on the surrounding properties away from the river. This wouldn't look any different after construction, simply just a need for the right to place the wall within that area. However, it will be the foundation, so it won't look any different in that red area particularly. The bottom left you will see near the barn, but not touching it in the barn, as mentioned, will be protected. The drainage area, which the drainage will be added on the left side. The pipe will run out through that way and into the channel. The utilities will are on the south side, not necessarily directly shown in this, will be shifted temporarily within the blue areas on the south side of the road as needed, so that we can put a crane on one side to pick and move the 100-foot pieces, and then switch sides and pick and move the 100-foot pieces. Crane will need sufficient room to swing with safety, which is why the utilities must be moved prior to construction. And without further ado, I will pass it along to Zach Moreno with DOT to talk more about rights of way.
And thanks, Connor. Again, my name is Zachary Garino, and I'm a project coordinator with the department's Division of Rights of Way. Our office is responsible for acquiring the property rights needed for transportation projects. And as Connor mentioned in the presentation, this project will require the acquisition of property rights, so I'd like to give a brief overview of our acquisition process. Before I begin, I'd like to mention that specific impacts are still being finalized and they may change as the design progresses, and that any required property rights will be acquired in accordance with Connecticut General Statutes, Sections 13A 73, 13A 98E, as well as the Uniform Act. You can go ahead and change the slide. So the right-of-way acquisition process begins once the design has progressed to a development milestone and all the impacts have been determined. At this point, each affected property owner will receive a formal letter of intent to acquire from our office, along with a property map which depicts the exact property rights to be acquired. And on the screen here is an example of a property map that an owner may receive. It's going to show the existing conditions as well as the proposed improvements specific to each property. So next, our office will determine the fair market value of the property rights which are depicted on that map and use it to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available to meet with the property owner and explain the project, go over the specific impacts to their property, and explain how the state arrived at its offer. The property owner will be given a reasonable amount of time, typically 30 days, to consider the state's offer and enter negotiations. When an agreement is reached, the department will prepare all the necessary paperwork to record the deed and property map on the town line records. However, if agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights through its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court, along with a monetary deposit in the amount of the state's offer. The owner would have 6 months from that date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner. And it's important to note that the state only acquires property rights that are needed for this specific project. And if there are any questions regarding the right-of-way acquisition process, I can answer them after the presentation. With that, I'm going to hand it back to Connor. Thank you.
Thanks, Zach. So, quick little bit more of information before we move on to any questions that may be waiting. So, we anticipate to advertise this project next summer in 2026, with the construction notice to proceed first being available in November of the same year, which, due to the winter shutdown period, would likely push the construction into the spring of 2027. Bridge work duration for the full reconstruction of this bridge is expected to take up to 16 months, with the construction finishing sometime in the summer, potentially fall of 2028. The estimated construction cost at no cost to the town will be $12.6 million. As previously mentioned, 80% federally funded and 20% state funded. And I believe with that, we have wrapped up the technical portion of the presentation and are ready for questions.
Thanks a lot, Connor. Good job. All right. Well, now, as Connor said, we'll turn over to the formal Q&A. You can reach out to us through the Q&A function in the Zoom, or you can call by phone or email us. Looks like we have 2 questions right now. The first question is from David Jacobs, who is a 2-part question. 1, how much increase in project cost would be incurred if a temporary single-lane bridge was provided rather than using a 2.5-mile detour? And the second part of the question, could you use a continuous span over pier rather than 2 simple spans, thus decreasing superstructure depth and increasing clearance over the water? Connor, I'll kick it over to you to answer.
Yeah, thanks. So in regards to a temporary bridge, the first part of the question, it's not so much the cost, which was partially considered. It's more so the difficulty of spanning what will be now a 200-foot bridge temporarily, with the excavation of the causeway occurring as well. Just did not find that to be feasible in previous studies of the project. And then the center pier was considered a necessary structural component for the support of the bridge. The bridge will be raised to accommodate the greater superstructure depth.
Great. Thank you, Connor. The next question comes from John Eberly. Can you address 2 items? 1, what impacts to navigation for waterway users, kayaks and canoes, for people upstream during construction in summer and early fall period? And 2, impacts, benefits for expanding the bridge to 2 spans and doubling the span opening. Connor?
I'm sorry, Mark, could you please repeat the question? I didn't quite hear you.
So the first part of the question was, what impacts to navigation for waterway users, for people upstream during construction in summer and early fall period? So navigational impacts, and once you answer that, I'll get to the second part.
There are some known users, as mentioned, nearby for the river. We anticipate keeping the channel open for fish passage during construction. We do anticipate minimal impacts. And if anybody else has anything to add on this one from VHB.
Yeah, Connor, I'll jump in. It's Tom Ryan with VHB. We are planning to, like I said, maintain the channel during the full construction duration. We will not be closing it, but there may be some temporary closures due to setting steel and things like that. The channel will remain roughly the same opening. It will probably be impinged upon a bit by sheeting driving to construct the pier and the west abutment.
Okay, and then the second part of the question was, what are the impacts or benefits for expanding the bridge to 2 spans and doubling the span opening?
I can chime in on that. So the benefit to increasing the span length of the bridge is it does improve the hydraulic performance in combination with the added drainage to the left side. So that will be no longer an issue on the bridge. And that was one of the main reasons And again, if anybody has anything to add that I may not be
Yeah,
stating right
let me
now.
I'll help out a little bit there again, Tom Ryan. We wrestled with this one as to whether it would be 1 or 2 spans from day one. We originally designed it as a single span and looked into what it would take now to rebuild the causeway. As we got into design, we did borings out there. We found the soil is very, very poor. So we were going to have to construct pile supported tall pile supported retaining / wing walls on that east side, all the way over to, I think, around 17, section 17. The cost of that compared to a new structure was about the same. And we did a life cycle cost analysis. We found out the life cycle cost, even with the additional maintenance, was about the same. DEP had also, or DEEP, had also weighed in that they would like to have increased tidal flushing activity upstream. And so we're trying to do some restoration of that upstream tidal estuary area. It was a bonus to going 2 spans. And again, the cost of future maintenance are about the same. So we thought it was a win-win situation. We still feel that way.
Thank you, Connor and Tom. Next question comes from Dan McMahon. With the increase in traffic onto Black Point Road from Route 156, will the DOT consider allowing turning right on red at the intersection of 156 and Black Point Road at Smith's Acres? This will allow traffic to move much more quickly.
I don't believe that the signalization was considered as a change for this project. I believe that the detour route, although inconvenience, will be the best way to conduct traffic throughout this project.
Yeah, but
Awesome.
on that route, Connor, let me jump in again. Connor's newer to the project, so we're not trying to overdub him on this, but our other project engineer, we switch people. So I did a lot of the design, so let me try to explain. When we do a detour route, we actually have the consultant engineer who's going to design the bridge go out and drive it. We do a detour checklist, and it tells you what's good and bad and indifferent. When we do that drive through and we fill out that checklist, we will evaluate from a capacity standpoint whether right on red is a good idea with some of the warrants that we have for it. So it will be absolutely looked into. I can't guarantee it because, again, we look at warrants for this, for the stop. And if you have poor sight distance to the left or a school, there's several different things that are considered to determine whether the State Traffic Commission would advise that or not.
Thank you, Tom. The next question is a follow-up from David Jacobs. You misunderstood my second question. I meant keeping the center pier as part of the project, but using continuous intermittent beams over the center pier rather than 2 simple spans or indeterminate beams.
We did look at continuous spans. What for fully continuous? Right now, what we're proposing is what we call live load continuous spans. They will be continuous for live load, not for dead load. In order to put in dead load or fully continuous spans, we would have to construct the 200-foot beams somewhere and then bring them in as one piece and set them on the pier and do it. And with these site conditions, that's not realistic to think that way. We'd have to put false work up in the tidal waters, build it on that, and then try to pick it and set it with cranes from both sides. Just too much of an arduous task. And the live, you don't gain much. You don't decrease or gain much superstructure depth by going from live load continuous to fully continuous. The beauty of the continuous is it's going to be a jointless bridge over that pier. So either way, that's what we're going to be coming back with.
Thank you, Tom. Next question comes from Joshua Caskey. Was Connecticut's complete streets policy referenced in this project? Related, why are bike lane or sidewalks on both sides of the roadway not included in the design as recommended by CTDOT's complete streets policy? Just to start, because this is a municipal project, it is exempt from the complete streets policy because it's a municipal road and CTDOT does not have final authority over the road. For the federal local bridge program, what we generally do is we discuss it with the town and ask them what their long-term plans are and what they would like to see incorporated, whether it be wider shoulders, sidewalks, bike lane, et cetera. And that's what we've been doing as part of this project. If Connor or Tom want to expand on that, please feel free.
No, that's it in a nutshell, pretty much, Mark. Again, it's something you could take up with the town. Is we discussed this with the town. I don't know if they want to weigh in, but we presented that section and they endorse it at this point.
All right. Alex Close from East Lyme has his hand up.
Sure. So Alex Close, Deputy Public Works and Acting Town Engineer. The situation would be, we did want to get a sidewalk over the bridge, but we also recognize that that now means we need to get safe passage to that sidewalk, which is going to be a task in itself for the town. So a sidewalk on both sides of the bridge, on some kind of crossing or some kind of connection on what's already kind of a narrow roadway, was not something that we wanted to take on. So we requested to have a sidewalk over the bridge, with the understanding that now we've got to connect that sidewalk and make good use of it to have it on both sides, with such a narrow roadway after the bridge just kind of didn't make sense for, again, because of the width of the roadway, the width of the right of way here, the volume of traffic. We felt that just one side would be sufficient in this case. I hope that answers the question. And if you have any other sidewalk specific related questions, you can go ahead and reach out to Joe or myself.
Thank you. Thank you, Alex. Next question is from Spencer Beers. How much higher will the new bridge be compared to the existing one? Tom or Connor, if you want to take that.
The new bridge will be raised like less than a foot from the original.
Okay, thank you.
Mark, I'll jump in. This is Greg Garish. Just to add to that, the vertical clearance of the bridge will be raised about a half foot over the channel. So if that's, was intended for the question, the vertical clearance will be a half foot higher for this condition.
Right now, we're not seeing any questions. We can give it another couple of minutes before concluding. Question from Kate Rattan. How are flood and storm resilience considered in the design of the bridge and adjacent roadway? Greg, if you want to take that one.
Yeah, I'll take that one. Let's start with the hydraulic performance of this bridge was pretty good to start for existing. So the 500-year flood or design storm flows through the bridge with underclearance to the low port. So that is now increased by raising the low port of the bridge, or the bottom surface of the bridge. Of course, we considered sea level rise for the state of Connecticut. DEEP has adopted a 20-inch sea level rise through the year 2050. With that sea level rise included, the 500-year through design storm would not overtop the bridge. The FEMA still water elevation is just higher than the roadway low point of bridge, which is 9 feet. The still water elevation is 9.4 elevation, but that elevation includes a wave action element, and it's not expected for wave action to necessarily make it this far upstream. So with sea level rise, if wave action were to make it this far up, the west approach, where the low point of the bridge, the low point of the roadway is located, would be inundated by just over a foot to a foot and a half of water. So it'd be inaccessible at that point. But as is anticipated, the 500 years expected to flow through the bridge.
Great. Thank you, Greg. Give another couple minutes. Again, thank you for your participation. We encourage you to fill out the post attendee survey. And as stated, if you have a question that comes up after tonight, you can reach out by email, by phone, and visit the project webpage for helpful information. Oh. Question from Matthew and Angela Kukowski. Will the utilities run through the bridge when completed?
Yeah, I can speak to that. So the utilities will be temporarily relocated to still run over the bridge during construction, and then when it's done, everything is going to go back to original configuration as you see it today. There's expected to still be sufficient room for existing conditions to continue forward after the new structure is built.
And this is Mark from VHB. I just want to add that these are butted beams. They're adjacent. They're right next to each other, so we can't really fit the utilities in between the beams. We did discuss the potential future water main that would be on the outside, but the other utilities will stay aerial.
Thank you, Connor and Mark.
This is Alex Closey, and I wanted to add one point about the utilities. We keep mentioning the future water main. I just want to make it clear for the residents on the call. At the time of the bridge construction, it's not that we're going to guaranteed be installing a water main. It was that we, the town, with the coordination of the water department, requested that the bridge design consideration be that in the future, if we extended the main, the bridge would be able to support the water line. So I just want to make sure that's clear. It's not that the bridge is going to go up and then there's going to be a water line, guaranteed immediately. It's that if the demand is there and the water department ends up running that line, the bridge won't become a problem in the future, and that we'll have the ability to do that.
Okay. Thank you, Alex. And we'll leave it open for one more minute and then we'll conclude. Again, thank you all for your participation and your attendance in this public info. This is very helpful for us to further develop the project. We're going to wrap it up tonight. Oh, another question from Matthew and Angela Kowski. Do we have access to the slideshow? Yes. We can post that to the DOT webpage for the project. I'll just verify that right now. We can either put it on the public informational page or we can provide the town with it to get you a copy, but we will be able to provide a copy of the slideshow. Okay, with that, I think we can conclude. Again, thank you all for your questions and for attendance. We greatly appreciate it. Have a pleasant evening.